Let's do it.
All right. Happy Thursday, everybody. Welcome to today's webinar. Just doing a little banter while people seep into the webinar as Zoom lets everybody in. So we're glad to have you today. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And today we're going to have Zach Carson, a pre-sales technical specialist and application engineer from PTC, give us a review of Creo Simulate. And also on our panel today is industry veteran Bill Stickney. Bill has been with 3HTI probably for about 14, 15 years, and this is what he did at Laird before he came to work at 3HTI. Laird was a customer, so Bill has extensive experience with finite element analysis as well as computational fluid dynamics. So he's on hand to answer any questions that any of you may have. So this webinar is probably going to take about maybe 20 minutes, and Zach's going to take you through a handful of presentations and a demo of Creo Simulate. Basically, this is a tool that is part of the Creo suite, so it's embedded. And the whole idea is that if you have an analyst downstream to run a detailed analysis, if there's any changes that need to be made to that model and it has to go back to design, that's going to make a tremendous delay and it's going to cost money. You're not going to hit your deadline and it's going to be a problem. So what Simulate does is up front, designers and engineers can use this tool to not just design for form and fit, but also function at the same time. So now when it goes downstream to that analyst, there's no changes that would be made that are necessary. And if you don't have an analyst downstream, then that's where Creo Simulate comes in. It becomes an analyst tool for you. And of course, the level of detail that you need is based on the type of product that you're making. So anyway, without further ado, I'm going to let Zach take the con and start through the presentation. It's all yours.
Thanks for the intro there, Rob.
You're welcome.
All right, so yeah, we're going to get into a PowerPoint first, just to introduce everyone to Creo Simulate, and then afterwards, we'll jump into the demonstration. All right, so Rob already touched on a couple of these things, but when it comes to challenges in the realm of analysis, there's some pretty common ones that we see. First, when it comes to analysis in engineering companies, it's typically something that just the experts do, but in reality, that's definitely not the best way to go about it. It's expensive, it's time consuming, and the reason for this is just historically been software limitations. And that itself can cause a lot of problems. It puts you behind track with data translation issues. There's poor communication at times. And then as Rob just said, it takes time to actually just go back and forth, to send it off, to do the analysis, to return it, to make changes, go back to the analysis. It wastes a ton of time. And doing analysis like that almost always means you're just doing it to catch problems. It's not actually being used to find the optimal design like ideally it should be, especially if you're not doing it until the end. This thing is already designed. You're ready to build it. And then, oh, wait, we have a problem. That's a really expensive way to go about doing things. Waiting until the end to find out if you've got any issues, and then go through redesigning, sending it for analysis again. That makes a really expensive fix. It's very time consuming, and it could be completely avoided if you would just have done this earlier in the process. And if you had a tool to support that. Creo simulates the solution to these challenges, and the solution that's sort of pass-fail mindset. It's built into Creo Parametric, so there's simulation integration, and it gives you the ability to implement analysis much, much earlier in the design process so that you can understand the quality of your design. And then by the time you get to a manufacturable ready product, you've already worked out the kinks and you have the best possible design. Now, Creo Simulate is structural and thermal analysis so you can understand product performance and optimize digital designs. Make sure that you're actually putting out the best possible design you can have. And it's all part of Creo Parametric. You're not using a third-party product. You're not going to a different interface. You simply say, this piece, this part, let's turn it on and analyze it. And this enables you to get analysis involved much earlier in the design process. Rather than analysis just being used in the end, like I said, as a pass-fail, it actually becomes a tool that you can use that guides your decision-making and validates your designs. Using Creo Simulate, you can do things like optimization and feasibility studies to determine if there's a better way of doing something. What happens if I make this wall thicker and that wall thinner? Do I actually get a better product? Not just does it fail, is there actually a way to make this thing better? In Creo, you can do this. You can analyze the geometry. You can make those changes very quickly and easily because it's in the same tool. Then you just update the simulation models and rerun the analysis. Everything's being done in Creo. And again, it's leading us not to just some answer, it's leading us to the actual right answer, to the best design. So with Simulate, you're getting a full suite of analysis tools. There's tons of options here for you depending on what you're working with. You can take a look at all these. We have static structural, buckling, nonlinear, large deformation nonlinearity, dynamic and pre-stress analysis. The list goes on, really just whatever you would need to run your analyses. Okay. Now, when it comes to meshing, a lot of times this is considered to be a specialty. There's meshing experts out there. This is like their worst nightmare, but Creo Simulate's all about automatic meshing. We just let the system go and do it. It's going to optimize the meshing for you. So it basically refines it in areas it needs to be refined in to give you the best results. And then after the fact, if you're looking at the mesh and you really want to go in and tweak it for whatever reason, or maybe refine it in certain areas, you can always override that automatically generated mesh or just select on those specific areas and refine it in those regions. Okay, and this is the case with anything that you're meshed with when it comes to meshing. It's a full mesher, whether you're doing solids, shells, beams, springs, masses, whatever the case may be. So again, we're trying to see if this is going to do more than just break. Let's do optimization and feasibility studies to improve designs. Let's take these walls, change them from a 1/2 inch to a 1/4 inch and see what happens. So we use that feedback to drive decisions and to make the best designs. It lets you explore and try some what ifs to be innovative with your designs. That's what it's really all about. See how your products are going to hold up in certain conditions, in certain scenarios, and those changes you make to the model are going to seamlessly be pushed over into the analysis. So you'll know the effects of those changes much, much faster. On top of that, it's very easy to parametrically vary properties in your simulation model because you're just doing the analysis on your CAD model. They're not separate from one another. It's the same exact model. It's in the same exact system. So pushing those changes over to the analysis is extremely, extremely simple. Afterward, when you've run the analysis and you're looking at the results, we have templates that make it really easy to see everything. You can look at different variables, different contour plots, stress, deformation. You can animate it, anything that's going to help you to just get the best understanding of the quality and the functionality. And then the results you get, you can output those as various formatted reports for documentation, or you can just send them off to somebody that needs to see them. I mean, you can see here MPG, VRML, Excel, TIFF, HTML reports, all kinds of different options there. You can also use a simulation query that gives you an exact result for anywhere you click on the model. So let's say you're looking at von Mises stress. You click here, it's 100 megapascals. You click here, it's 60 megapascals. Anywhere that you want to see a value on the model, you just click on it and it spits out that value for you. And in the end, this is just designed to be extremely easy to use. It's easy to see the results. We have the template for you, as you can see on the screen here. You can see different types of plots. It's easy to interact with, so on and so forth. So without further ado, we've gone through the presentation here. Let's go ahead and jump into the demo. All right. Rob, can you see Creo now?
I can. I see the model.
Awesome. So for this demonstration of Creo Simulate, we'll be working with this machine press that we have. Now, this is a new design. It's held together with this frame around the outside. We also have some lifting lugs over here to actually put this in place when it gets in the shop. Now, these lugs are something we've used before, but not in this exact instance. So we need to make sure they're actually going to work. And that's where Creo Simulate is going to come in. It's all being done in the same interface. We just go to the applications ribbon at the top, and then we click the simulate icon. And then at that point, we're in the simulation. We can start to do our setup. We can put in any loads we have, any constraints, specify different materials. You might do that as you're actually designing the part, but this is all being done in Creo. So we're going to start today by just putting a constraint in. We'll select edges and curves, and then we'll just select on these edges. That's where I want to hold the part. And then we can go ahead and put some loads on this thing. So we'll put loads on the holes. That's where the attachments are going to go. We'll just select both of these. We can also put a point load out in space. We'll give that a value as well. And that's just going to simulate how the weight's actually going to be held up on this lug. All right, and then I can apply those loads and we can preview them. So that's going to show up on the model. So we can see exactly what we've set up and verify it's what we want. In this case, it is. We basically have that force twisting this piece in two different directions. It's exactly what we wanted. So now we have our constraints. We've got our loads. Let's go ahead and actually run the analysis. And we have some different options here. We can go to run this. We can do a static, modal, buckling, fatigue, pre-stress, dynamic. There's lots of different options. In this case, we're just going to keep it simple. We're just going to do a static load. We'll go ahead and the constraint and the load that we just set up are already here. We can change if we want to do multi-pass, single pass. Say we want to get within 6% convergence value. These are all things that you're just going to specify depending on what sort of accuracy you need. And then once that's set up, you just go ahead and run it. This is a very simple case, so it's not going to take long to get our results. Run's already completed, and then we can just go ahead and look at the results here.
So here's a question. Here's a question.
Sure.
To stop. And so with Bill on the line, how long does it normally take to run and get results? I know this is a pretty straightforward and simple analysis, but I was just wondering what the average time is and how this compares to other tools.
This probably is about the average time for a simple solid model. If you have a more complex model, it requires shells or beams or other idealizations, it's going to take you a little longer. Compared to other tools, it's probably much faster. You can knock out answers awfully quick with this.
And when you say much faster, you mean like hours and sometimes even days?
With some of the other tools, yeah. Yeah, what's important here is you can test out design ideas at the rate of maybe 3 or 4 a day, possibly more, whereas it might take you a month to do that same work with an older style tool.
Mm-hmm.
So, and it turns out that the quality of your design is based primarily on how many ideas you have tested and refined. And it's more important than the absolute accuracy of the analysis in most cases. So very efficient tool.
Thanks, Bill. All right, Zach. Sorry for the interruption, but I thought it was
no,
it was pertinent.
Yeah, it's good. Good input to have. All right, so here we've got our our contour plots and everything set up. This is basically the template that I was talking about that you can see results in. So here we basically on the left-hand side, have the animation here for the von Mises stress. We have our displacement magnitude fringe in the middle. You can change what you're looking at there. It doesn't have to be displacement. But in this case, we're looking at a stress level of about 19,000 PSI. So that's definitely, in our case, not going to work. It's way too much for this particular material. So the question is, what can we do now? Well, we're doing all this analysis on the actual design. It's not a copy or anything like that, like I said before. So making a change is actually very simple. And this is where being able to do everything in one system is such a huge advantage. Moving between systems takes time. There can be data translation issues. Just the time it takes to go back and forth is a lot of time that can be avoided. And I mean, based on what Bill said, I mean, if you're doing this, 3 or 4 times a day for these changes versus a month, I mean, you can imagine what that's going to do for you, how much money it's going to save, how much time it's going to save. And as a result, I mean, you're not just getting more, testing done on your design, it's saving money. I mean, you're also being more innovative. You can also try out so many more design options, create new designs, things like that. So for this change, there's different ways we could go about this. We could just make the plate thicker and stronger. Maybe there's some weight concerns though that we have with this, so we don't want to go that route. Instead, we're going to set up a sensitivity study. And what we're basically doing is saying, run those analyses, but when you do it, let's change something. In our case, that fillet area with the radius of 0.20 right there is where the stress level was really high. So what happens if I change that? But instead of me changing it, I want to let Creo change it for me in so many steps over a certain range. And what happens then is when we run everything, we can go ahead and tell Creo basically to give us a graph of the von Mises stress once it runs and gives us the results. And that way, then we can look at that for all the iterations we ran the analysis on and determine what's the best. Maybe we can look at it and see a trend. Maybe we just gain knowledge and understanding of the design. Regardless, it's going to be really beneficial for us. And Creo's doing all the heavy lifting. Okay, so looking at this thing, I mean, we had a value of 0.2 there for the radius, which is right at the about 19,000 von Mises stress we were just at, which is way too high. We want to get this thing about at 11,000 or less. So the value that's going to give us that looking at this plot is going to be 0.4 for the radius. With that information that we have now, we have some options. We could go back to the model and just change that value to 0.4. That's the easy way out. And we know that that's going to be a better model than what we have. Or we can rerun this and we can have the system tell us exactly what value that radius should be to give us the absolute best design. And that's exactly what we're going to do. We're going to tell Creo, again, do all the grunt work for us. We're going to set up this new optimization design study. And in this case, I don't want to just expand that radius. I don't want to just make the thing fatter by changing the radius. So I'm going to tell Creo, minimize the mass of this part. We can set up different limits. So let's say for this, I want to stay under, for this max stress, 11,000 PSI.
That's a good point, Zach. In a lot of cases, adding more material is not the answer.
Exactly. And yet, this is one of those cases. Yeah, I mean, adding material is definitely going to make it stronger. But then you get into the issue of you don't want to use more material. It costs more money. Might make it take longer to fabricate or whatever the case is. There's a lot of other ways that we could go about this that would probably be better. So that's what we're going to do here. I mean, we're telling it the goal is to minimize the total mass. Then we can just put in our limits. So we already put a max stress limit in of 11,000 PSI. We can also put in max displacement magnitude because we don't want this thing, bending and warping all over the place either. We'll say 15 thousandths of an inch. And then we can start to put in different variables as well. So we threw a range in there. A lot of other things we can do though. What if I went in and I said, change the height of this, change the width, change the length of this lug, change the thickness if I want to. There's all these different options that would probably take hours to go through just to set up all of that for every little detail, to change each one individually. But the idea is you don't have to do it. You don't have to take all that time. What we can do instead is we can select different things here, different variables, and they're going to be put into this spreadsheet for us where it's really, really easy for us to look at all the variables we've defined and then input different values. We can set up ranges, input our values all from this one little spreadsheet that we brought up just by clicking on the different geometry on our model. All right, and what we can do from here then is we can tell the system, take everything in this spreadsheet and run the analysis. And it's going to keep our goal in mind, keep those design limits within the analysis, look at all these different variables, and it's going to calculate for us the absolute best possible design that we can have based on that criteria. All right, and again, that would take hours, days for us to do. Instead, we just let Creo do it. We let Creo handle the grunt work. And what it's going to do is it basically tries options. It says, are the limits satisfied? Are we getting towards the limit? Are we moving away? It's going to move back and forth. And it does as many iterations as it needs to find the optimized shape for the part within the constraints that we just laid out. right? And already that run is completed. So you can see how fast this thing is running, even with all of that criteria that we specified. And once this is done here, we can just look at what this new model is going to look like, what the optimized model looks like. And here it is. So in this case, it's a lot different. Much bigger fillets. It's bigger on the outside. We have a smaller tab, definitely. We can even go in and review this thing to actually see what Creo did to get to this model, what all it changed. So in this case, we're going to go to optimize history. And you can see here what all it's changing. Each dimension, it's making the tab on the left a lot thinner. It's making it shorter on the top and the bottom. It's pushing that radius to higher and higher values, seeing how that affects it. And this is giving us, like I've said before, this isn't just a pass-fail design that we have now. This is the actual optimal design for this part that meets all of that criteria and all of those design goals that we laid out. And then right away, you can push it onto the assembly, and you can see here now we have that updated log on this assembly. Okay, and that's all being done in Creo Parametric using Creo Simulate. So that's all that I had planned to go through for this today. I don't know, Rob, are there any questions?
I have a question.
Sure.
I have a question. So here's what my question is. So one of the things that we know that makes Creo unique is that you can open up a SolidWorks file or CATIA file or a Unigraphics file in Creo. You can read it. Now it's not smart geometry. My question is if you bring that into Creo, is there a way to then use Creo Simulate to run the analysis on it?
Bill, you might have more experience with this one.
Short answer is yes, it works. The Simulate program does not require a model tree. It is going to operate on whatever geometry it sees. So imported geometry can be run just fine. The only problem you would have is what Zach just showed you with the parametric optimization is not going to be so easy because you don't have dimensions in a model tree to vary. Now, you can weasel around that in some cases by using flexible modeling tools that allow you to actually parameterize certain dimensions in a model. Would work with simple geometry at least. So you might be able to do that. But as far as just running it and making models, you know, with shells or whatever, there's really no difference at all. Works fine.
That's good to know because for anyone in our audience that's using a different CAD system, this clearly would work with a license of Creo, and just a base license Creo and Creo Simulate, and you're able to run this analysis and off you go.
Yeah.
I
So, Rob,
think
there
that's
is-
tremendous.
Oh, sorry.
I think that's tremendous that this tool can do that.
Yeah. There is one more thing I wanted to show, Rob. I did want to look at or show the packaging a little bit, just so
Yeah.
everyone has a good idea.
Please
This is
do.
what the packaging looks like. There is different levels to Creo Simulate. So we have, basic Creo Parametric can do some simulation. Then you get into the Simulate extension. So that's the middle category. You can go through and see what kind of an analysis you would plan on running and see if it meets the criteria. So just the standard Creo Simulate extension does a ton of different things. If for whatever reason that's not meeting your criteria, you could go into advanced simulation extension, which literally does just about anything you can imagine is going to be covered in that.
So, I mean, just to let everybody know, keep this up for a second. So
Sure.
we actually had a customer who had purchased several licenses from us that was doing a project for the government, and they called me and asked for a price of Creo Simulate. And I started asking questions about what they wanted to do, what they needed it to model, what they needed to run analysis on, and everything. And it was the response from the customer was, no, don't want to get into that now. We just need a price because we need a quote because we're bidding on a project. And I said, well, how do you know you need Simulate? We just need it. So it was like very adamant about just getting the price. So we gave him the price. And 2 months later, we get a call back. We won the bid. We want to buy Creo Simulate. Okay, great. What are you going to use it for? And then they just want to buy. They just want to buy. And I said, look, I think it's a good idea if we have a conversation. Bill's an expert. So Bill was on the phone. We had a conversation with these guys, and they wanted to figure out or run analysis on using vibration. And the response was, you can't do it with Simulate. You guys are going to need Simulate Advanced. So moral of the story is we would not sell them Simulate. They ended up buying it from somebody else, and it was like, what are you guys doing? And then they couldn't use it because it didn't do what they needed it to do. So I guess the point of what I'm trying to say is, if you feel like you need simulation, Creo Simulate, whatever, talk to us, because the goal is we don't want to sell you Simulate Advanced if you're not going to use it when you could use the Simulate extension, and vice versa. You know, if you don't buy enough capabilities, then the product doesn't do what it needs to do for you. If you don't buy enough capabilities, if you buy too little capabilities, it's still not going to do what you need it to do. So we're here to guide you guys and, you know, help make a good business decision to what you want to accomplish, and that the software is a good fit. I had another customer call me up. They wanted Creo Simulate Live, and they're a medical device company. I know a little bit about what they do, and I couldn't understand why they would want Simulate Live. I could understand why they would want Advanced, but not Live. And we had a conversation, and they're like, okay, you know, what they wanted to accomplish was kind of very intensive. So they ended up using us for a project instead of actually buying the software, which actually made sense. So that's another option regarding Simulate. We do analysis services, engineering, design services. So for a lot of our customers, if it doesn't make sense to buy the software because you don't know how often you're going to use it, but you have a specific project, or you want to run a project to get familiar with it, that's where we come in. And overall, that can, you know, just be a smart business decision in the short term and the long run. So that is my 2 cents. And what I want to do is I actually want to share my screen for a quick second. So if you need any assistance or have any questions, feel free to reach out to me. You can email us at info@3hti.com. You can respond to the emails that we sent you regarding as an invitation to this webinar. If you respond to those, they come to me. So I'd like to thank everybody for being on today. I'd like to thank Bill for his time and being a panelist, and also Zach. I mean, Zach's done the past couple webinars for us. I think he does a great job, and we're lucky to have such a great relationship with PTC and get the support that we have, because overall, that's when our customers benefit. So Bill and Zach, thank you. To our audience, thank you. We're going to be dismissed, and have a great day and a great weekend, and look out for another email for our webinar that we're going to have next Thursday. Take care, everyone.